Okay, so we are looking at one last example here of how to factor the polynomial and find all zeros. So here our polynomial is, so let me rewrite, there was a typo in there. So this is equal to 2x cubed minus 5x squared minus 28x plus 15. So this is our polynomial. And if you look at it, I don't think anyone can see a factor or a zero like directly. So we will use our tips or our steps that we have learned here. Okay. So we will start by writing the constant term. Which is 15, and lead coefficient, which is 2. So now we write p, little p. What is little p? It are all the divisors of the constant term. So which is 15. So what are the divisors of 15? 1, 3, 5, and 15. But remember, when we put them here, we are also taking the negative divisors in consideration. Plus minus 1, plus minus 2, plus no 2 is not a divisor, right? 3, plus minus 3, plus minus 5, and then plus minus 15. Okay. So now I can write the q here, but I encourage you to write the q under the p. That way it becomes easier to do the division and you don't have to think much here. So q, because we are looking for divisors of 2, so we have plus minus 1 and plus minus 2. So now I will be looking for possible values of p over q. So that one set of values will come from this by dividing all the p values by that, and the other set is going to come by dividing the set all values of p by this value of q. So I will write them in the different pens. You can see. Now, first one is value of q is plus minus 1. Now you know that when we divide by 1, we get back our number. So if I divide by negative 1, I just have to just put a negative sign, otherwise it's the same number. So plus minus 1 over plus minus 1 gives me just plus minus 1. Plus minus 3 over plus minus 1 gives me plus minus 3. Then plus minus 5 over plus minus 1 gives me plus minus 5. And similarly, we get plus minus 15. Now when we divide by plus minus 2, we will get plus minus 1/2. Now when I divide, the next one will be 3/2. Then we will have 5/2 plus minus 5/2 and plus minus 15/2. Okay, these are the possible values. Now we check one by one. These values, we plug them in p. So we start by the first value, which is 1. So I find p of 1. So I'll get 2 times 1 minus 5. 1 is pretty easy to check. So now you may go ahead and do the calculation, but basically we are looking for a 0. Will this be equal to 0? That is my question. Well, by looking at the numbers, I can see that this is already a big negative, bigger than this plus 15 number. So it's not going to give me, so I'm not worried about what the value is. I just want to know that is it going to give me 0. Then you check negative 1. For negative 1, be careful, because when you do negative 1 cube, you get negative 1. Okay? And then minus 5 into negative 1 square will be plus 1. So if you want, you can write it this way, but it takes a little time. So I'll get negative 2 minus 5 plus 28 plus 15. So again, this is not going to give me a 0. So next value, 3. Okay, 2 times 3 cubed. What is 3 cubed? 3 cubed is 27, but we'll come back to it. Minus 5 into 3 squared minus 28 into 3. Actually, I should put these powers or exponents outside the parentheses, because with the positive value it doesn't matter much, but the negative value changes the scenario. Okay, plus 15. So this is 2 times 27 minus 5 times 9 minus 28 times 3, which is 3 8s are 24, 3 2 is 84. So 54 minus 45 minus 84 plus 15. So this is no way going to give me a 0. Next one, 2 negative 3 squared minus 23 into negative 3 plus 15. So I get 2 into negative 54. Sorry, just negative 2 into negative 27, not negative 24, negative 27. 5 into positive 9, and I can multiply this one. It gives me 84 plus 15, which means negative 54 minus 45 plus 84 plus 15. So if I add the negative numbers together, I get 99. If I add the positive numbers together, I get 99. So it gives me a 0. Oh, at last. So now we found negative 3 is a 0. So by factor theorem, what does that give me? That tells me that x plus 3 is a factor of the the px of the polynomial. So now we will divide by this factor. X cubed 2x cubed minus 5x squared minus 28x plus 15, and I'm going to divide it by x plus 3. So the first term in the dividend divided by the first term in the divisor, which is x. So I get what 2x squared. So I will put it over here on top of x squared term, 2x squared, and multiply 2x squared with the whole divisor. So I get 2x cubed, put it under the x cubed terms, plus 6x squared, parentheses, negative sign outside, read it at 2x cubed minus 2x cubed, so it cancels out. This gives me a negative 5x squared minus 6x squared, so I get negative 11x squared. Okay, what is the next one? So we bring down the 28x. So now I have to divide this first term by the x, so I get negative 11x. So negative 11x, put there, multiply the divisor, put a negative sign here. So negative 11x squared plus 11x squared will cancel out, and then I have negative 28x plus 33x, which means we have 5x left, and then plus 15. So this gives me, put plus 5 up there, get a 0. So which means I can write my p of x as x plus 3 times the factor, the quotient 2x squared minus 11x plus 5. So now we have to see how to factor the this quadratic. Now if you can do the factoring directly, you should. If not, then you can use the quadratic formula. So this actually factors out very nicely. 2x squared minus 11x plus 5. Now if you are doing the guessing method, you may put the, we write like this. So we know one of the factors should have a 2x, and then the other factor should have an x, so that when we multiply them, we get the first term 2x squared. Now we have to figure out what goes in the second terms of each piece. So because the result, the last term is 5, so one place we have to have 5, and in another place we have to have 1. So probably 5 will go here and 1 will go here, because then you will have a you will get the 11x, because 2x times 5 will be 10x, and 1 times x will be x, so 10x plus 1x, 11x. And since we want a negative sign, with that we have both have negative sign. So that p of x equals x plus 3, 2x minus 1, x minus 5. So these are the factors of the polynomial. And so you can say that, so this is the polynomial in the fully factored form, and then you can see that we have 0 are negative 3, 1/2, and 5, and each of multiplicity one. So this is how we do this problem.